Hello students, now we're into part D, properties of parabolas, and here I'd like you to explore with Desmos. So Desmos is an app that I love. You can get it on your iPad or your computer, and it's free and it's web-based, and you don't even have to use it with the web. You can also get a version that just downloads to your iPad. So using Desmos, we want to look at f of x equals ax squared plus bx plus c. So let me show you how to do that. So go to your web browser, whichever browser you prefer. And here I've gone to desmos.com. And so you go to desmos.com and you have this option to launch calculator. So I'm going to hit launch calculator. And then you can sign in using your Google account. The benefits of signing in is that you can later save your graphs to Drive. So if you click on sign in with your Google account. So it already knows who I am, emilyS@isb.ac.th. So it's going to let you put things into Drive. So I'm going to say accept. All right, so now I'm going to come in and put in this graph. So you can use these buttons down here. I much prefer to type them, so I'm going to get rid of those. And I'm just going to type in f of x equals ax squared. So to make this squared with the keyboard, it's shift and the number 6, puts me up top there. And then I'm going to use my right arrow to get out of the exponent, plus bx plus c. And now it gives me this option to add sliders, and I want to add all those sliders. So if we think back at our parent function, we had that b was equal to 0, and c was equal to 0, and a was equal to 1. So what I want you to do is to create this and to play with these sliders. What happens when we change our a values? And be looking for interesting features, like if a is 0, what happens there? And why does that happen? If a is 0 and b is not, what's happening? And let's think about those things. But if a is negative, what do we see? If a is a decimal, what do you see? If a is a number bigger than 1, what do you see? And then I'm going to put a back to my normal 1. And you can click and type also if you want an exact value. And now I'm going to play with b and see what changing b does to my graph. So thinking about those sorts of ideas. If I take my b back to 0, now I can play with c. And then of course you can play with many of them and see what happens. So all of these things you're supposed to be exploring, and you're going to explore those to try to answer these questions. When does the graph open up, which is also called concave up, and when does it open down? The graph is narrower than the parent, so if I also want to see the parent, then that could be useful to me also. So I could add in another equation here of y equals x squared. So now, thinking back to wider or narrower than the parent, if I come back to my original, where I had a equals 1, b was 0, c was 0, of course that is the parent, and I had noticed that a was changing wider or narrower, and so that's what you want to be thinking about here. When we talk about it getting wider or narrow, that's dilating the graph. Figuring out the axis of symmetry. This one is a trickier one. So I suggest you use easy numbers. So I'm going to add in the axis of symmetry. Our current axis of symmetry is x equals 0. Whoops, x equals 0. There's our axis of symmetry. Now, if I change, let me make this back to 1. Actually, let's make it into 2. And then I'm going to play with my b value. So now I see that my graph has changed. So I'm going to try and put it somewhere. Let's make this exactly 4. All right, so now it looks to me like my axis of symmetry is x equals, looks to me like it's -2. Oh, that's not correct. I should have looked at how I was counting. It looks to me like it's -1. All All right, so I want to figure out how are A, B, and C affecting the axis of symmetry. And I want to try and come up with a formula. Right now, A is 2, B is 4, and the axis of symmetry is -1. So that's what you're thinking about, trying to find a formula. Right now, if I just said that x was equal to A, I get a line over here, and I can see that as I change A, my axis of symmetry changes. If I make x equal to -A, well, it's getting closer, but of course it still has to be a lot smaller. So let's go back to what we had seen clearly when it was 2. We know that it needs to be -2. A is 2, so I could think, we know it needs to be -1, so I could think that this was half of A. And so right now that works. My idea for the axis of symmetry works, but now if I change B, my graph moved, but my axis of symmetry didn't. So my axis of symmetry must somehow use the B also. So if I come back to what I knew before, well, let's look at it here. Now my A is 2, my B is 0, my axis of symmetry needs to be x equals 0. So maybe it's A times B divided by 2. And now as I change B, that is not working. So these are the things that you want to be playing with. And I'll tell you that you need to get rid of the 2 for sure. So be playing around with that. Make numbers that are easy to see. I think 4 and 2 might make numbers that are pretty easy to see. This one looks like it's, well, I'll let you figure out where it is and try to make an equation that matches. Clearly this number has to get a lot smaller. It needs to be over here in the middle. On Desmos, I could drag this down to see it more clearly. I can also use my wheel to spin in. I could have used the zoom in buttons over here as well. And so those are some Desmos hints. All right, so for sure finding a formula for axis of symmetry, x coordinate of the vertex. We find the y coordinate of the vertex by just substituting into the function. And then some things for you to read here. What is the y-intercept value? And some more things for you to read based on, for properties of parabolas. We're gonna come back and in the next video do the example. Make sure you go into the notes and check your answers here. I'm gonna come back and fill in these answers. So make sure you come back and check them.